All right, so we've all seen AI do some pretty wild stuff, right? It can write poetry, create absolutely stunning art. But what about thinking? I mean, really thinking, logically from step A to step B. Well, a fascinating new paper is tackling exactly that, one of AI's biggest challenges. So let's break it down.
It's kind of a paradox, isn't it? These AIs can be incredibly creative, but when you give them a complex problem that requires step-by-step reasoning, they often just stumble. So the central question that researchers are really digging into is this: how in the world do you teach an AI to really think? To get why this new research is such a breakthrough, we first need to understand the fundamental hurdle they're trying to get over. And for an AI, solving these complex problems really comes down to a single and surprisingly human challenge. It's called the credit assignment problem. Okay, imagine you're a student working on a really long math problem. You're making dozens of little calculations along the way. Now, if you get the final answer right, fantastic. But how do you know which of those specific steps you took were the brilliant ones? That right there is the credit assignment problem. And for an AI, it's a huge, huge challenge. So in a typical training process, the AI goes through all these thinking steps, but it usually only gets feedback on the final answer. It sees that big green check mark, gets the good job, but it's left completely guessing which of the steps it took to get there were actually correct. It's kind of like a teacher who only grades the very last page of your homework and ignores all your work. Now, the current state-of-the-art method for training AI reasoning is a technique called GRPO. It's pretty powerful, but it relies on that exact same pass/fail approach we just talked about. It only grades the final result. So this leading method, GRPO, is fantastic in a lot of ways. It's a really efficient reinforcement learning method. It's the best we've had for this kind of thing, and it's lightweight because it's critic-free. But it has this one big flaw. It still suffers from the credit assignment problem. It gives the AI's entire chain of thought just one single grade. The whole thing either passed or it failed, with absolutely no nuance. And this brings us to the breakthrough, a brand new idea building on GRPO that teaches the AI to value the entire problem-solving process, not just the final score. So here's the core difference, side by side. The old way, GRPO, just grades the final answer. It's that all-or-nothing reward. But this new method, called GRPO lambda, acts more like a really smart teacher. It actually spreads partial credit back to every single correct step that led to the right answer. This is a huge shift from grading the result to grading the process itself. So, how does this spread that credit? Well, the secret sauce is this really cool concept called eligibility-traces. Just imagine that each step in the AI's thought process leaves behind a little breadcrumb. When the final answer turns out to be correct, the reward literally travels backward along this trail, reinforcing every good decision that led to that success. It's a way of connecting the final win to all the smart moves the AI made along the way. If we go back to our math problem, just look at the difference here. Instead of just one single checkmark at the end, GRPO lambda sends that credit all the way back up the chain. Now the AI learns that, hey, understanding the question was a good step. Identifying the right formula was a good step, and so on. This builds a much stronger, much more robust reasoning ability. And the researchers found a fascinating little twist. The absolute best results came when they put extra weight on both the beginning and the end of the thought process. This kind of suggests that correctly framing the problem at the start is every bit as crucial as arriving at the right answer. You need a strong foundation and a successful conclusion. Okay, so the theory sounds great, but does it actually work? This is the exciting part. Let's look at the proof. Let's look at the numbers. And the results are, well, they're pretty impressive. On average, a 7 billion parameter model improved its math benchmark scores by a massive 4.5 points using this new GRPO lambda method. Now, in the world of AI benchmarks, that is a significant leap forward. And the results get even more dramatic. On a particularly difficult math competition benchmark, one called AMY24, the new method delivered a stunning 10-point improvement. To be crystal clear, this isn't some minor tweak. This is a total game changer for the AI's ability to solve high-level math problems. And this improvement wasn't just a one-time fluke. The data here shows that the GRPO lambda method consistently outperformed the standard GRPO across a whole variety of different AI models, from smaller 1.5 billion parameter models all the way up to larger 7 billion ones. The pattern is clear, it's consistent, and it proves this new approach is robust. This isn't just about getting higher scores either. It's also about efficiency. The new method improved training performance by 30 to 40%. What that means is the AI doesn't just get smarter, it learns to be smarter a whole lot faster.
So what does this all mean for the future? Well, this breakthrough isn't just about making AI better at its math homework. No, it has much, much broader implications. This kind of improved reasoning is really the key to unlocking AI's potential in so many other fields. Just imagine an AI that can assist in scientific discovery or generate complex, bug-free software from a simple prompt. Pretty much any task that requires a solid, logical chain of thought is going to benefit from this breakthrough. The big takeaway here is captured perfectly in this idea. By teaching an AI to value every single part of the problem-solving journey, we fundamentally change how it learns. Shifting the focus from the result to the entire process, that unlocks a way more powerful and intuitive level of reasoning.
And that leaves us with a final thought to chew on. We're seeing AI begin to master the kind of step-by-step logic that for a long time we thought was uniquely human. So if it can conquer high-level math today, what truly complex problems in science or medicine or engineering is it going to solve for us tomorrow?